I am Parkavi, working as Assistant Professor of Mathematics in Erode Sengundar Engineering College. Now we discuss about the topic subspace. We already know the space. We denote the space, let B be the vector space over a field F. We denote the subspace. W of V is called a subspace of V. The subspaces are W1 and W2 belongs to W, and alpha, beta are scalars belongs to R. Implies that which is alpha plus beta of alpha of W1 plus beta of W2 belongs to W. It satisfies the condition. It's called subspace. Now we see about some theorems. Prove that W is equal to A, 0, 0. A belongs to F is a subspace over a field F. Consider the space W1. W1 means A, 0, 0. And consider the another subspace W2. It's called B. So W2 is equal to B, 0, 0. The W1, W2 subspaces belongs to F because the field F. To prove W is a subspace of R cube. To prove the subspace, it satisfies the condition alpha of beta 1 plus beta of W2 belongs to W. So we denote alpha of W1 plus beta of W2 is equal to alpha of W1 means A, 0, 0 plus beta of B, 0, 0. So multiply alpha in both sides. So alpha A, 0, 0 plus beta B, 0, 0. So we add the alphas. So alpha A plus beta B, 0, 0. So the alphas and betas are in W. So alpha of W1 plus beta of W2 belongs to W. So W is a subspace of R cube. Next we prove that intersection of two spaces of a vector space is a subspace of V. Now we have to prove, consider two space W1 and W2 is a subspace of V. So let us consider V1 and V2 are two subspace of V. Take A, B belongs to V1 and A, B belongs to V2. So to prove that V1 and V1 intersection V2 is a subspace of V. By using the subspace definition is W1, W2 belongs to W and alpha, beta belongs to F such that alpha of W1 plus beta W2 belongs to W. So consider since V1 and V2 belongs to V and alpha, beta belongs to F such that alpha V1 plus beta of V2 belongs to V1 intersection V2. Since alpha and beta are V1 and A and B are belongs to V. Hence V1 is a subspace of alpha A plus beta B belongs to V1. Since alpha 1 beta belongs to V2 and AB belongs to V2. Hence V2 is a subspace of alpha A plus beta B belongs to V2. From equation 1 and 2, alpha A plus beta B belongs to V1 and intersection V2. Hence V1 intersection V2 is a subspace of V. Next we have to prove that the union of two subspaces of a vector space need not be subspace. That means the union of two vectors, that means V1 union V2 is not a subspace. So let us consider A equal to A, 0, 0 and A belongs to R and B is equal to 0, B, 0 for all B belongs to R. Since we already know W is a subspace of R cube. So since A and B belongs to R cube. Now we take A, B equal to 1. So substitute in equation A and B, we get 1, 0, 0 belongs to A and 0, 1, 0 belongs to B. So 1, 0, 0 union 0, 1, 0 does not belongs to A union B. So A union B is not a subspace of R cube. So the union of two subspace of a vector space need not be a subspace. Next we see the another definition of subspace. A set W of a vector space is a subspace of V if and only if the following properties are hold. The first property, x plus y belongs to W and x, y belongs to W. And the next condition, Cx belongs to W. Here C is a scalar function. So x belongs to W and C belongs to F. And the next condition, 0 belongs to W. And the next condition, each vector in W has additive inversion in W. So we have to prove the four conditions, the satisfies the four conditions called a subspace. Now we see the theorem. Let V be a vector space and W be a subspace of V. Then W is a subspace of V if and only if the following three conditions hold for the operation defined in V. The first condition is 0 belongs to W. Second condition is x plus y belongs to W whenever x belongs to W and y belongs to W. And next condition, Cx belongs to W whenever C belongs to F and x belongs to W. First we have to prove a necessary part. Assume W is a subspace of V. Now we have to prove the three conditions. Already we know that W is a subspace. We have to prove the four conditions. Already the three conditions are hold. Now the operation defined in V, since W is a space, vector space of F which with the operation defined on V, which is implies that xy belongs to W such that x plus y belongs to W and also C belongs to F and x belongs to W such that Cx also belongs to W. If defined 0 belongs to W and x belongs to W, then we add the two operations 0 plus x is equal to x. So 0 belongs to W. So we can take x plus 0 dash is equal to x. So x plus 0 dash is equal to add 0 plus, so 0 plus x. So 0 dash is equal to 0 belongs to W. Hence the three conditions are hold. Next we have assume the necessary part. The three conditions are hold. Now we have to prove W is a subspace of V. So we can take 0 belongs to W, x plus y belongs to W whenever x belongs to W and y belongs to W. Cx belongs to W whenever C belongs to F, x belongs to W hold for the operation defined in V. So by using subspace definition, the four conditions to prove. Since x belongs to W and minus additive inverse means already the three definitions are hold. Next we have to prove the fourth definition, additive inverse. The additive inverse is minus. So x belongs to W and minus 1 belongs to F. So minus 1 into x belongs to W. So minus x belongs to W. Hence minus x is the additive inverse of x in W. Hence W is a subspace of V. And next theorem, prove that a subspace W of a vector space V is a subspace if and only if alpha of W1 plus beta W2 belongs to W for all W1 W2 belongs to W and alpha comma beta belongs to F. Assume W is a vector space of V. So we have to prove if and only if conditions. So assume W is a subspace of V and we have to prove the alpha W1 plus beta W2 belongs to W. So we can take W1 W2 belongs to W and alpha beta belongs to F. So alpha of W1 belongs to W and beta of W2 belongs to W. So as W is a subspace, we have to prove the condition alpha W1 plus beta W2 belongs to W. Hence alpha W1 plus beta W2 belongs to W and for all W1 W2 belongs to W and alpha beta are scalars, so this belongs to F. So assume that alpha of W1 plus beta of W2 belongs to W for all W1 W2 belongs to W and alpha beta belongs to F. So by using the theorem, we know the theorem. W is a subspace of V. So already we have to prove the three conditions. And the first condition is 0 belongs to W. So we can take W1 W2 is equal to W and alpha is equal to minus 1 and beta is equal to 1 such that alpha W1 plus beta W2 is equal to alpha means minus 1. So minus 1 W1 plus 1 into W2. So minus W1 plus W2. Now we have W1 W2 is equal to W. So we substitute minus W plus W is equal to 0. Then the first condition is called 0 belongs to W. And next condition, W1 W2 belongs to W and alpha beta equal to 1. So now we have to substitute alpha W1 plus beta W2 is equal to W1 plus W2. it belongs to W. And next condition is Cx belongs to W. So let W1 is equal to W and W2 is equal to 0 and alpha and beta belongs to F, such that alpha W1 plus beta W2 is equal to alpha of W. W1 is equal to W. So we have to substitute alpha W plus beta into W2 is 0. So we have to substitute beta into 0. So alpha W belongs to W. Hence W is a subspace. So the three conditions is satisfied. So it's called a subspace. Now we have to prove that. Now we prove that hence W is a subspace of V.